Alright, so continue this couple questions here. Determine if this Y is in the subspace of R4 spanned by the column of this. Basically, we are looking for if there is a solution for this matrix equation. Okay, that's basically what we're looking for. So or equivalent to see, is this non-homogeneous equation consistent or not, right? So we can list the augment matrix. Well, it will take some time to figure out the corresponding echelon form. So I'm gonna write it down. Okay, I'm not gonna do this part. I think you can work on this by yourself. 0, 0, 90 over 61, 0, 0, 0, 0. And so clearly you can see that there is a pivot in the first three columns. So we're all good. So yes, it is in the span because the system is consistent, meaning there exists an X there. In other words, Y can be returned as a linear combination of the column vectors from this matrix A here. And another thing I want you all to notice that is there is actually a website. I really encourage you to give a try. It's called the Matrix. Cal.org. Okay, so it's a matrix calculation cal.org. Wow, that's very handy. So you put it into the entries for the matrix, and then you want to calculate this. Try the echelon form inverse determinant. It will give to you. Okay, cool. Now, second, so find a matrix such that the given set is the column of this matrix A, and then RST, those are real numbers. This one should be pretty simple, right? So what we can do here is you can write it down as R 0, 1, 4, 3 plus S, so it's 2, 1, 1, negative 1 plus T, right, times 3, negative 2, 0, negative 1. And then, so just stack them together. 0, 2, 3, 1, 1, negative 2, 4, 1, 0, 3, negative 1, negative 1, and then we're done. Okay, so just simple. This is the second question. The next question is given here. Given this set, including those following vectors, is this set is a basis, linear independent, span? Well, the thing is, this vector, first of all, it cannot be linearly independent. Why? Because you have this zero vectors, right? So they have zero vectors here, so cannot be linearly independent. Okay, and then if it's not linear independent, so hence it's not a basis, right? It's not a basis. The other thing is this spans R3, and clearly it is not, right? It is not. Why? Because it's not linearly independent, and also the other way you can think about it is 0, 0, 1, negative 1, 0, 0. So the reduced echelon form, actually, as you can see here, 0, 0, 0, right? So it's like this. In other words, there is now not the reduced echelon form does not have a pivot in every row. So there is no way that it's going to span R3, right? If there is a pivot in every row, then yes, it's going to be span of R3. So there's no pivot on the third row, hence not span R3. Okay, simple. This one, see? Okay, here we go. So assume that A and B are row equivalent. Find the corresponding null space, column space, row space. This is one of the example we already discussed before. So column space is simple. So the pivot, it's the first, third, and fifth. So the column. So basis for the column space, it's 1, 2, 1, 3, negative 5, negative 5, 0, negative 5, right? And negative 3, 2, 5, negative 2. Okay. And then the basis for the row space is just row vectors, right? Except the 0 vector. It's going to be 1, 2, 0, 4, 5. You can also write it down into a column vector. Wait, it doesn't matter. 0, 0, 5, negative 7, 8, and 0, 0, 0, 0, 9. Okay, that's it. Just kind of fun. So the null basis for null space of A. Well, you do need to do slightly a little bit things, but here is the x2 and x4 are the free variables, right? And the x5 equals 0. So that's what we can tell directly from this matrix B. So x1 equals negative 2x2, negative 4x4, x2 equals x2, right? Because of free x3, let's see, equals 7x4, right? So it's just 7x4, x4 equals x4, x5 equals 0. So when you put this all together, noticing that your x can be represented as x2 of negative 2, 1, 0, 0, 0, right? Plus x4, so it's going to be negative 4, 0, 7, 1, 0. So the basis for the null space, it's negative 2, 1, 0, 0, 0, and then negative 4, 0, 7, 1, 0. Okay. So yeah, that's it. Okay. So hope you enjoy this. Thanks.